Yeah? You don't have the second page? There's no heading on the second page. It's the same notes. Yeah. Good question. All right. So, data can be represented in three ways. We've already seen it on a table. We've also already seen it on a graph. We can also write an equation. That's going to be what we're transitioning into today and tomorrow. So, let's look at this graph. It looks a lot like our warm-up. This graph represents the... Fellas right here, please stop talking. Okay, don't worry about the cap to the glue. All right. This graph represents the proportional relationship between the number of, well, what are the two things based on what you see on this graph? What are the two things we're comparing here? Look at the axes. What does it say on the axis?
School days.
Number of school days, that's my X. And the number of hours in the school, that's my Y. So, this graph represents the number of days in school and the number of hours in school. Now, of course, this is going to be a proportional relationship because we know the more days we're in school, the more hours that we're at school, obviously, right? So, just like in our warm-up, we see a bunch of dots on this line. Let's take a look at this first. Well, actually, how many? 1, 2, 3, 4, 5, 6, 7. Yeah?
What does it say up there? Like the right hand?
Yeah, I can't see something.
I got you. Days. Is that a little bit better?
Days.
All right, I'll use this pen for yellow, then I'll retire this one. It's too light.
The yellow.
Mm-hmm.
The yellow looks bad.
It's okay. So let's take a look at this very first point all the way down here. What do we call this point? Everybody should know this point by now. What do we call this? The origin, all right? The origin represents how many days of school?
0.
0. It also represents how many hours in school?
0.
0 again, and that makes sense. If I've gone to school 0 days this week, I've spent 0 hours at school. But this next point represents how many days at school. If I look straight down, how many days at school does that point represent? 1 day. And if I look over, how many hours are in that 1 day at school? 6. Everybody see how we pulled those two numbers off there?
Yeah.
All right. If I look at this second point, how many days does this second point represent? If I look straight down to my x-axis, how many days are there? 12. Oh. If I look down to my days, how many days?
2.
2 days. Now how many hours are in those 2 days?
12.
There's my 12, okay? So I really have to be careful that I'm not mixing up my x and my y, because when I go to find k, my y needs to be on top, my x needs to be on bottom. So if I mix up which one is my x, which one is my y, then I'm going to mix up my k, okay? Okay. The third point, how many days does this third point represent?
3.
3 days. And how many hours?
8.
18 hours. And what about this fourth point here? How many days?
4.
4 of them. And how many hours?
24.
24.
So,
Oops.
why is there a 5?
24. Now, we could keep going 5 days, 30 hours, 6 days, 36 hours, but I ran out of room on my table, so I'm going to keep it at that. That's really all we need. It's actually more than we need. So if I want to find k, what do I need to do with the table?
Finding y over x.
Find the y over x. Well, what can I draw on either side of this table to find out what my numbers are going to be? We're going to do our little what? Our little arrows, okay? How do I get from 0 to 6?
Plus 6.
I'm adding 6. What about from 6 to 12?
Add 6.
Add 6. What about from 12 to 18? Add 6. And 18 to 24? Add 6. Give me a thumbs up if you see a constant change in y on the right-hand side. Amari sees a constant change. Michaela, Rawaz, Muhammad see a constant change. Alasia sees a constant change. Avery sees a constant change.
I do.
Lukamba sees a constant change. Johnny, yep. Billy. Good. All sixes. What about on the left-hand side? How would I get from 0 to 1 to 2 to 3 to 4? What do I add each time?
1.
I'm adding 1. Plus 1. Plus 1. Plus 1. Plus 1. All right? So far, nothing new. We did this yesterday. We did this Monday. Now again, just like in our warm-up, if I want to find the value of k, I've got to put that change in y over that change in x in a fraction or a ratio. So if k is equal to y over x, what am I going to put in place of that y based on this table? 6. 6 hours. What am I going to put in place of the x?
1.
1. 1 what?
Hour. Day.
Day. With me so far? All right. So 6 hours every 1 day. How can I simplify 6 over 1? What is that? It's just 6. What are my units going to be? Yeah, Ayana?
6 hours per day.
Good. 6 hours per day. And that represents how long we spend at school. 6 hours a day. I think we're here a little more than 6 hours. But for this example, 6 hours a day. So now what we're going to introduce is this equation, right? We already have one equation, k equals y over x, all right? But now we're going to write an equation that represents this data. The equation looks like this. Go ahead and do a nice big old cloud around this because it's important.
How is your cloud so good?
I've done too many of them. It doesn't matter how your cloud looks, that's all right.
Okay, bet.
So this equation reads y equals kx. Everybody repeat after me. Y
Y.
equals
Equals.
k
K.
times
Times.
x.
X.
Y equals k times x.
Y.
Thank you, Amari in the back, for doing that. So y equals k times x. It looks very similar to k equals y over x, right? It's just kind of rewritten. All we need to do with this equation is plug in the value of k that we found. What did we find k to be equal to in this situation?
6 hours.
6 hours a day. So I'm going to take this, I'm going to plug it in right there. Boom. This is my equation that represents this line. Y equals 6x. What this equation represents, as we know, is the proportional relationship between the number of school days and the number of hours spent in school. All right, and in this equation, I'm going to highlight the y in pink and the x in yellow as well. All right, you guys' notes look great. There you go. Let me just throw that in 6 right in that blank spot. So look at the color coordination here. Pink. My pink represents the number of hours spent in school. The yellow is the number of days, right? So this equation says my total number of hours spent in school is equal to 6 times the number of days. So if I'm at school for 2 days, what is 6 times 2? 12 hours. That's exactly what we saw on our table. Okay? If I'm in school for 10 days, what's 6 times 10? 60. That'd be 60 hours. We don't have space here, but we could figure that out. So for those of us that were doing the ALEKS yesterday, did anybody realize that you could just multiply the number it gave you by each of the numbers in your X?
That's
Yeah.
what I did.
You were using this formula, you were using this equation without even realizing it. You were taking the K value, multiplying it by the X coordinate, and that gave you your Y coordinate. That's all this equation does. All right? Quick show of thumbs, how much sense is that making? Thumbs up, sideways, down, good. Where are we at? In the middle maybe? That's all right, good. Okay. Am I going too fast?
No.
I heard someone say yeah. I'll slow down. Flip over to the second page.
I looked and forgot to glue that in, so.
I know.
How do you get it glue in, right?
How can you tell a relationship is proportional? Let's first look at a table. We've seen tables the most out of anything. Proportional relationships have a constant change. We already know that word, right? What does constant mean? Over and over again, repeating the same. Those all mean constant. We have a constant change between each Y and X value on a table. We already know this. We defined this on Monday. Constant change between Y and X. So let's look at table A. What are the two things I'm comparing in table A? Hours and miles. Right? If I look at my hours here, I got 1, 2, 3. What would my, here, let's do it in yellow, like always. My miles are going to be in pink. Trust me, you may be annoyed at taking off the highlighter and capping them and keep going on and off with the caps. But when you have a test in front of you and you're like, shoot, I have no idea which one is which, you open that notebook up and you see all these nice colors, it'll help your brain kind of figure out what to do in that situation, right? So my hours. How do I get from 1 hour to 2 hours? What am I adding there? I'm adding 1. How do I get from 2 hours to 3 hours? I'm adding 1 again. Is that a constant change in X?
Yes.
Yeah. It was the same number both times, right? That's constant.
Yes.
Over here, how do I get from 7 miles to 14 miles? Plus 7. Good. Thank you, everyone, for saying that. What about 14 to 21? Plus 7 again. Is that a constant change?
Yes.
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 Let's go over to table B. We'll table that for a second, and we'll go over to table B. Table B is also comparing the number of hours with the number of miles. For my hours, how do I get from 1 to 2? I'm adding 1. How do I get from 2 to 3? Adding 1. So far, so good. Looks pretty constant to me. Let's check the miles. How do I get from 6 to 10? Plus 4. How do I get from 10 to 12? Plus 2. Ah, good observation, Johnny. It is not a constant change. What this second table tells me is that, I biked 4 miles in an hour, and then I really, really slowed it down. In that second hour, I only biked 2 miles. Does that mean I'm driving at a constant speed? No, I was going fast, and then I slowed down. Over here, I went 7 miles in the first hour, 7 miles in the second hour. I'm traveling at a constant speed, right? So which of these tables has a constant change? Table A has a constant change. Therefore, what type of relationship can we say table A represents? Good. Proportional. Now for table A, how can I find the K value of table A? What would K be equal to here? What over what?
7 over 1.
7 over 1. Give me a thumbs up if you agree with that. That if I want to find K here, I got to put 7 over 1. Xavier agrees. Michaela and Avery. Muhammad. Ayana agrees. Kayla agrees. Osna. Good. So if I wanted to find K here, I could say K is equal to my pink 7 over that yellow 1. What is 7 over 1? 7. What are my units on that 7? Good. 7 miles per hour. You can put MPH. Now, if my units end up being something like kilometers per second, I'd prefer you write, km/second instead of kmps, because I'm not going to know what that means. But yeah, miles per hour is a common one. You can put MPH. We cool on that? Okay. So on the ALEKS, you're going to get a couple of tables, and you're going to have to see which of these has a constant change and which of these does not. All right? If it does have a constant change, that means it's proportional. I can find my K value rather easily. If it's not a constant, can I find a K value here? What do you guys think? No. So underneath table B, write no K value. Because remember, K stands for constant. If I don't have a constant change, I can't have a K. Right? What questions can I answer about all that? Almost done. I can see I'm losing some of you. Let's look at a graph then. Proportional relationships on a graph appear as straight lines. Straight lines. So if I see a straight line on my graph, I've got a good idea this might be proportional. But not only does it have to be a straight line, but it has to go through the origin. What are the coordinates for my origin again? 0, 0. Okay, and I put little slash marks through my zeros so you don't think they're capital O's. So just get used to seeing that if you haven't seen it before. So let's look at graph A. Here's graph A. We're talking about the number of weeks and the total amount of money saved, right? Anybody in here get an allowance? Parents give you a couple bucks every week. You guys save that money or you spend it right away? You spend it. I appreciate your honesty. Anyone save their allowance? A couple of us? Good, good, good. Some of us do. That's great. So as the weeks go on, the money in your savings goes up. Now if you spend some of that money, it's not going to be proportional because it's going to go up and then it's going to go down because you spent it, right? Does graph A look like a straight line to you?
No.
Whoa. What's your definition of a straight line? No, okay, let's be careful, right? The first thing is this orange line, fellas right here, third time. Is this orange line a straight line? Yes. It is a straight line. But does it go through the origin? No. Here's my origin right there. So, hey, Mr. Pauly.
How are you?
Good. How are you?
Hey, I'm still looking for your test. I know you need one.
Yeah,
Like that one?
I pulled that one from right here where the fridge is in. So if you can't find one, I'm good. I got what I need. And the
Okay,
fridge is
okay.
fine on there. No one was using those crates anyway, so it's fine. Yeah. But if you do find one
I
that's...
find something else to put
I'll
that
put it-
one,
yeah, yeah, yeah. Okay.
Because that's the one you need, right?
Yeah, that's the one I need.
Okay.
I appreciate it. Thank you, Mr. Pauly. So, this is a two-parter, right? Is this a straight line? Does it go through the origin?
No.
It has to be both to be proportional. It has to be both to be proportional. So while this is a straight line, it does not go through the origin. Everyone cool on that?
Yes.
Is graph B a straight line?
Yes.
Yes. Does graph B go through the origin?
Yes.
Yes. You guys see the difference between these two?
Yeah.
Okay. Good. Which one of these would be proportional? Give me a thumbs up for graph A is proportional. Give me a thumbs down for graph B is proportional. Good. I see all thumbs down. That is absolutely right. Graph B is proportional. What are the two things about graph B that tells me that it's proportional? Who can tell me what one of them is? Michaela? It goes through the origin. Good. Johnny, what's the second thing?
It's a straight line.
It is a straight line. Straight line that goes through the origin. If graph B is proportional, what can I call graph A?
A, not proportional.
Non-proportional. We're not going to worry too much about that yet. That'll be next week. But graph A is non-proportional because even though it's straight, it does not go through the origin. So on graph B, I want you to write prop, graph A, non-prop. Just like that. So this lesson is called representing proportional relationships. I can represent them through a table, through a graph, and through an equation. I can also identify whether something is proportional or not. If I have a table, I'm doing my arrows and looking for the constant change. If I have a graph, I don't need to do my arrows. I just need to look for a straight line that goes through the origin. All right? Now, for graph B, I'm going to zoom in here so we can see. How might I be able to find the K value of graph B?
It's 10. It goes by 10.
Goes by tens? Yeah, it does go by tens. So look, see how the line crosses right here? I'm going to make this a nice solid point. See that point right there?
Yeah.
And this point right there, right there, right there. Everybody see that?
Yeah.
Okay. If I was going to find K from here, I got to take one of these points. I'm going to look down to my X value. Where does this point line up on the X axis? 1 week. Where does that point line up on the Y axis? 10 what?
Total amount saved.
10 amount saved in dollars. So $10 in 1 week. So the K value here, what number is going to go on top? The 10 or the 1?
10.
What number is going to go on top? The 10 or the 1, guys?
The 10.
The 10. $10 every 1 week. Well, what is 10 over 1?
10.
Just 10. $10 per week. Right, so I'm not doing my little arrows on a graph. I only do that on my table. If I have a graph, I got to find a point. I'm going to look down. I'm going to look over. Those are my two numbers that I need. All right. The more practice you get with this, the more sense it'll make, though. So if you're feeling a little iffy about it, trust me, the Alex will help kind of fill in those gaps. And we've got a lot of time to do it too, which is great. Give me a thumbs up. You finished yesterday's Alex.
Yeah.
All right. So I'm going to go through, if I have time today, I'll go through today. If not, I'll do it tomorrow and put those grades in. It's going to be out of 10, right? If you finish the Alex and you got like a 70 on it, then it's going to go in the grade book as a 7 out of 10. But if you want a 10 out of 10, just do the problems that you got wrong over again and get them right. That's all you have to do. You can do it as many times as you need to. All right? If you're cool with it, 8 out of 10, 9 out of 10, that's fine with me. That's how it's getting entered. If you didn't get it finished, if it's not turned in, it'll be put in as missing. This is really important. I need everyone to listen to this, okay? Because there's going to be so many Alexes and I have so many kids, I can't go through, and make sure, did Ukamba finish it today? Did he finish it today? Did he finish it today? If you finish an Alex assignment after I've already put the grade in, you have to send me an email on Synergy and say, hey, I finished A02. Hey, I finished A03. As soon as I see that email, I'll put it in full credit. You don't have to worry about it. But I'm not going to go through and recheck every single day because I got a lot to do. Does that make sense? You guys know how to send an email in Synergy?
Yeah.
Yeah.
Can I just come back to
Come after class for what? To do it or to tell me?
tell you?
Sure. Sure.